Today we are going to be performing a lab using a spectrophotometer. First, you will need to prepare 3 dilutions from your given stock solution. Once you have these dilutions prepared, use a transfer pipette to transfer each solution into a clean cuvette. Remember to use a different transfer pipette for each to ensure that you do not contaminate your dilution. Be sure not to overfill your cuvettes. The meniscus of the solution should rest on the line. In order to use a spectrophotometer, you will need 6 cuvettes. These should hold your stock, 3 dilutions, and your given blank.
Yay, you made it over the first hurdle. Now we get to play with the spectrometer. First, what you need to do is ensure that the machine is zeroed. This is where your blank will come in. Gently grab the texture 2 sides of your cuvette that contains the blank and wipe down the 2 non-texture sides with a cuvette wipe. Then place the cuvette into the machine, ensuring that the non-texture sides are positioned so that light can pass through them. Close the machine, hit 0, and you're good.
Now that the spectrophotometer is zeroed, we need to find the ideal wavelength to measure each dilution at. To do this, you will grab the cuvette holding your stock solution by the textured side and wipe down the non-textured sides with a cuvette wipe, just like we did with the blank. Then place your stock into the spectrophotometer and close the lid. Go to your scan program and hit Start. Name your file so that you'll remember it and hit Save. Allow the scan to run across all wavelengths, and the highest wavelength is the one that you should use on the rest of your dilutions. Ours was a little bit high, but it's typically around 560 for the stock that we used. Next, you will want to connect this wavelength to your reading software by clicking Connect.
Now that the spectrophotometer is all set up to scan your dilutions, you will now move to measuring the absorbance of each dilution. For each, you will grab the cuvette by the textured side, wipe the non-textured side with the cuvette wipe, and place it in the spectrophotometer, ensuring that light can pass through the non-textured side. Hit read, and after the absorbance has been measured, remove the cuvette and close the machine. Be sure to record each absorbance for the respective dilution.
Let's go back to scanning across all wavelengths while our other lab members are checking the absorbance of our different solutions. If you do not scan across all wavelengths, then you will not know the correct wavelength to scan your solutions at. This could result in too high of a wavelength or too low of one, which will both cause either no read or a completely inaccurate read on a solution's absorbance, which can mess with the graph in the end. Generally, solutions absorb around the wavelength where absorbance is maximum, which is called the lambda max. So this is why you usually look for the highest wavelength on your scan to measure the absorbance of your solutions.
When you're asked to find the concentration of an unknown, what you need to use is the Beer-Lambert law. An easy way to find the slope of your graph is to create a graph on Excel. From our graph, we can see that the slope is 33.458. When we plug that into our equation along with our other values, the unknown concentration comes out to be 0.014 moles over liters. The absorbance concentration graph is a linear relationship, so you can see that failing to zero the spectrophotometer can lead to an inaccurate absorbance reading that could affect this relationship.
You successfully use a spectrophotometer. Don't get too hasty though. Remember to clean up your lab area. Don't leave anything in the spectrophotometer lab and throw away each used chem wipe in the regular trash. Make sure to clean all glassware and cuvettes used and put them away in the designated areas. Wipe down your lab area, rinse off your hands, and you're good to go.